Hi students, good evening. Okay, so today we are looking at the session 4 in laws of motion chapter. So in Ilandu we are going to go to the main part, so which is the applications of the Newton's laws. இதுக்கு முன்னாடி நம்ம பார்க்கறதெல்லாம் என்னது, the basic understanding of what are these Newton's laws, in the context la இந்த Newton's laws வருது, and some of the very basic assumptions, like the assumption with regard to the rope or assumptions with regard to the pulleys, and adukaprom we have talked about what are the common types of forces that we use. Adella we have covered in the previous 3 sessions. From session 4 onwards, right? So maybe we'll have another 2 or 3 more sessions on the chapter. Idilende we'll have the applications of the Newton's laws. Okay, so applications of the Newton's laws and sonna mainly we look at the problems, right? These are all numericals only. We look at the numericals into 2 cases. One is the problems where we have equilibrium of forces. One is the equilibrium of forces. Okay, equilibrium of forces and another rima. When you take any object and the object mele irukra ella forces, if the total resultant of all the forces is adding up to 0 nu vechukonga, then we will say the object is in translational equilibrium. So another we will say the object is in translational equilibrium. Okay, there will be one more equilibrium that we will use when we go to the rotational motion chapter. Okay, adu pathi we will talk about it later, but inganadi, if the total value of all the forces acting on the object is adding up to 0 nu vechukonga, then what do we say? We will say there is an translational equilibrium and so. Okay, rendavathu enna theriyuma, if there is no equilibrium means we will say unbalanced forces. Actually equilibrium and solradhukku badala we can also use one more word, enna theriyuma, balanced forces and sollala. The equilibrium badala what we can say balanced forces. Okay, rendavathu enna, second situation will be unbalanced force. Unbalanced force enna theriyuma, there is going to be a net force acting on that object, adanala we'll see some impact. Okay, so 2 situations. One is when we have balanced forces, rendavathu when there is unbalanced forces. So thani thaniya nam paaka porom. First we will start our discussion with the equilibrium of that forces. Adukku ingonu per enna iruka, we can say balanced forces and sollala. Okay va? So parunga, the equilibrium of concurrent forces. Edukku nam indha concurrent and word use pannirukom theriyuma? Because when we are looking at forces acting on the object, all of them will be acting on the same object dana. All the forces will be acting on the same object. Okay, so let us say there are F1, F2, நிறைய force இருக்கலாம். We can have whatever number of forces. Okay, F4. When they are all adding up to 0, we will say what? The condition of balanced forces. எப்படி தெரியும் நமக்கு that they are all adding up to 0? If the object is at rest. இப்போ object restல இருந்து வெச்சுக்கோங்க, it means what? The total force acting on the object will be what? 0. இல்லனா if the object is in uniform velocity motion, adana நம்ம நியூட்டன்ஸ் லால படிச்சிருக்கோம். If the object continues to be in the state of rest, or it continues to be in the state of uniform velocity motion, then it means what? There is no external force acting on it. Or even if there is an external force, inga parunga, there are 4 external forces, and the external force or total value on solala or the resultant, that is becoming what? 0. So this is what we will say the balanced forces. So அப்படி இருந்தா then you know what we say, the object is in என்ன சொல்லுவோம், we'll say the object is in translation equilibrium. என்ன சொல்லலாம், we'll say the object is in what, translational equilibrium. இல்லைன்னா இப்போதைக்கு we can just use the word equilibrium. ஏன்னா அந்த rotation motion அந்த சாப்டர்ல தான் நம்ம அந்த ரெண்டாவது பார்க்க போறோம், which is what is called as the rotational equilibrium. So in the rotation motion we'll talk about one more type of equilibrium. என்ன தெரியுமா, rotational equilibrium. Okay, so anyway we are not going to discuss about it now. So when the resultant of all the forces is zero, then we'll say the forces acting on the object என்னது, we'll say it is a balanced force. Okay, அது எப்படி நமக்கு தெரியும், when the object is continuing to be in the state of rest or it is moving with a uniform velocity, அப்படின்னா that it means what, the object is under balanced forces. Okay, இதுல இருந்து என்ன, what is the outcome that we can generate. For say for example the four forces, இங்க இருக்கிற four forces are balanced force னு வெச்சுக்கோங்க. So already we are able to understand that the object is at rest means what, இங்க இருக்கிற அந்த நாலு forces are what, balanced forces. அப்படி இருந்தா then you can take the components, இது ரொம்ப இம்பார்ட்டண்டா, you can take the components of forces in any direction. நீங்க ஏதாவது directionல you take component of all the forces, they will still add up to zero in that direction. Okay, so இதுதான் நம்ம அந்த ப்ராப்ளம்ஸ்ல யூஸ் பண்ண போற கான்செப்ட். What is it? நாலு ஃபோர்ஸ் இருக்கா, பட் எப்படி நம்ம இந்த கோரிலேஷன் கொண்டு வருது, we take the components of the forces in any direction, then they will be adding up to zero in that particular direction. Okay, so பாருங்க, if say for example I will choose the horizontal direction as one direction வெச்சுக்கோங்க, I will choose the horizontal as one direction. இதுல என்ன தெரியுமா, F2 ஃபுல்லாவே ஆல்ரெடி இந்த ஹாரிசான்டல் டைரக்ஷன், அந்த மாதிரி F4 is also horizontal, F3 எப்படி இருக்கா, vertical. So அதுக்கு horizontal component இருக்குமா, it will not have, because what is the angle here, 90. For a vertical force will it have a horizontal component, இருக்காது. Then F1 is making an angle with the horizontal, அது component இருக்கும், என்ன தெரியுமா, F1 cos theta. பாருங்க அது component வரும், என்னது, F1 cos theta. So horizontal directionல what are the forces, F4 is there, அந்த மாதிரி F2 is there, and component of F1 which is what, F1 cos theta. So இங்க பாருங்க F4 is to the left side தானா, and F2 and F1 cos theta. So F1 நம்ம component எடுத்தா இந்த பக்கம் வரும், right side தானா. So F2 and F1 cos theta, அந்த ரெண்டு எந்த பக்கம் இருக்கா, right side. If we are saying what, the components of forces in any direction they will add up to zero. Add up to zero என்ன தெரியுமா, அந்த left side இருக்கிற value should be equal to total value on the right side. அப்போதானே they will be adding up to zero, ஏன்னா vectors, right. When the vectors will be adding up to zero, if there are two directions, the left side இருக்கிற total value should be equal to what, right side. If the left side total force is 10 newtons னு வெச்சுக்கோங்க, right side also total force should be 10 newtons. அப்போதானே they will be adding up to zero. So பாருங்க, what is the equation we'll have, and the F4 will be equal to what, right side la irukka, what is there on the right side, F2 plus, what is there on the right side, F2 plus F1 cos theta. Purida? So this is what we call as the balancing of forces in the horizontal direction. Enadhu, we call it as the balancing of forces in the horizontal direction. அப்படி பண்ணா அதுல இருந்து நமக்கு என்ன வரும், equations வரும். அப்படி பண்ணா அதுல இருந்து நமக்கு என்ன வரும், we'll get equations. அந்த மாதிரி என்ன தெரியுமா, we can also take, so இதுல நம்ம என்ன பண்ணிருக்கோம், we have taken the horizontal direction, அந்த மாதிரி we can also take the vertical direction. எடுத்து பாருங்க, if you take the vertical direction as the direction, இதுல என்ன தெரியுமா, F1 ஓட horizontal component ஆல்ரெடி நம்ம பார்த்திருக்கோம், F1 cos theta. அப்போ vertical component என்ன வரும், F1 sin theta தானா, vertical component என்ன வரும், F1 sin theta. ஓகே, இங்க பாருங்க F4 and F2 are horizontal, அதுக்கு vertical components வராது. For a horizontal force there will be no vertical component, for a vertical force there will be no horizontal component. அப்படிதானா. So வெறும் we are having the component of F1 which is upwards, F1 sin theta, and there is a F3 which is also down. இங்க பாருங்க, these two should add up to 0. Other than a concept, when there is a balancing of forces means you take any direction, நம்ம எந்த direction எடுத்தாலுமே அதுல the total forces ஓட addition should be giving us value 0. 0 ன்னு சொன்னா என்ன தெரியுமா, the upward force, what is this, F1 sin theta, and the upward force ஓட value should be equal to what, downward force. Downward force என்னது, what is the downward force, F3 தானா, so the upward force should be equal to what, downward force. இப்படி like we'll get equation 1 and the மாதிரி equation 2. So whenever we have balanced forces, அதுல இருந்து what we can derive, we can look at select directions. Okay வா, அது எப்படி நம்ம எடுக்கிறது, so here I said horizontal and vertical, but எப்படி, how do we come to the conclusion, based upon the way the forces are actually distributed. எப்படி அந்த forces distribute ஆயிட்டு இருக்குன்னு சொல்லிட்டு அது பேஸ் பண்ணி தான் we'll take the directions where we'll apply the balancing conditions. Okay, இதுல இன்னொன்னு என்ன தெரியுமா, we will be able to have only two equations. We will be able to have only two equations. Two equations anu சொல்றதுக்கு பதிலா I'll use we will be able to have only two independent equations. எத்தனை independent equations வரும், ரெண்டு தான் வரும். Because if you try to, I mean assuming we are in the 2D plane, assuming we are in the 2D plane, அதுல இருந்து we'll get only two independent equations. என்ன தெரியுமா, you take some other direction, ஏதாவது இன்னொரு direction எடுத்து பாருங்க, என்ன தெரியுமா, we are going to get an equation which will be a combination of this equation 1 and equation 2. எதனால, the force F1, when you resolve the force, right, we'll resolve the force into two components only, right. The F1 எப்படி, we'll resolve the horizontal component F1 cos theta, அதுக்கு அப்புறம் vertical component F1 sin theta. So we can apply the balancing of forces condition in how many directions, only two directions on any object, because we consider the forces to be in the 2D plane. எப்படி நம்ம assume பண்றது, we are assuming the forces to be in the 2D plane. அப்படி இருந்தா then we will be able to apply the balancing of the forces in how many directions, two directions. அதுல இருந்து நமக்கு two equations தான் வரும். இதை நம்ம கரெக்டா ஞாபகம் வச்சுக்கணும். Whenever we draw the free body diagram of any object, அதுல இருந்து we have this balancing of forces. In how many directions we can apply the balancing of forces, maximum two directions, assuming the forces are in a plane. Okay va, maximum two. Some problems என்ன தெரியுமா, we may have all the forces in only one line, ஒரே லைன்ல இருந்தா then you know the second equation வராது, we'll get only one equation. We'll see the problems, then we will be able to understand. Okay va, so if there is an equilibrium, அதுல இருந்து நமக்கு என்ன வரும், we can apply this balancing of forces condition. அதுக்கு நம்ம என்ன பண்ணணும், we have to choose the directions. So if there are many forces means, and the force or components நம்ம எடுக்கணும், we should take the components of the forces in those directions. Maximum எத்தனை நம்ம equations derive பண்ணலாம், we can write two equations assuming the forces are in the plane. Okay, that is the common scenario va. Maximum என்னது, we'll have the forces to be in the plane, இப்படி தான் இருக்கும். So we'll be able to write maximum how many equations, two equations. But ஒரு சில இதுல என்ன, we will not even be required to write the second equation. Second equation நமக்கு தேவைப்படாது, or we will not even have the condition to write second equation. We can solve the problem by just using one equation. எப்படி வருதுன்னு சொல்லிட்டு we look at the examples. பாருங்க, we'll start with the questions. இங்கல இருந்து we'll have mostly questions only. A block of mass 8 kg is hanging from the ceiling. எங்கல இருந்து, it is hanging from the ceiling to a rope. Okay வா, so என்ன பாருங்க, so ceiling எப்படி இருக்கா, அதுல இருந்து it is hanging to a rope. இப்படி இதோட mass என்ன 8 kg. Find tension in the rope. See, already நம்ம rope பத்தி நிறைய பேசியிருக்கோம். So we said what, if the rope is massless, then what we said, tension in the rope is same everywhere. Okay, if the rope is having a mass means then we have to be careful, but maximum na sonna madri for the NEET level examination, right, we will always have this condition only. So rope will be what, rope will be not having mass. Okay, but we'll see some problems where the rope is also having mass, adu nama paakalam. The maximum what is the thing, is a simple thing only. Okay, பாருங்க, so this object, right, this object is the 8 kg block. We have to find the tension in the rope. Okay, adukku enna theriyuma, the only thing is what, this is hanging from the ceiling, means what, this is hanging means what, this is like at rest, this object is a what, it is at rest. Okay va, so now there is a balancing of forces on this object. Enna irukka forces parunga, every object. So this is the free body diagram parunga, we are drawing the free body diagram for the block, 8 kg block, right? What is the g value? 10 meter per second square. So what is the weight acting on this? M into g, which is 8 into 10, எவ்வளவு? 80 newtons. That is the weight acting on the body. அது எப்படி இருக்கும்? Vertically downwards. அந்த மாதிரி this is connected to the rope. இங்க பாருங்க, it is connected to the rope. So rope connection இருக்கிறதுனால we will get what? Tension force. Remember, tension force acting on any body will be always into the rope dana. Tension force acting on any body will be always into the rope. Into the rope and சொன்னது இதுல vertically upwards. அவ்வளவுதானா? That's it. இதுக்கு மேல force கிடையாது. So on this object only two forces are there. என்னது? One is on the object of own weight, which is vertically downwards. அதுக்கப்புறம் there is a tension which is vertically upwards. இங்க பாருங்க, we are saying what? There is a balance forces. அதனாலதான் this is simply hanging. So balanced force என்னது? The total value of the forces must be 0. So அதுல இருந்து எப்படி இந்த equations கொண்டு வரது? We said what? We have to choose the directions. ஏதாவது direction எடுக்கணும். Maximum we can take how many directions? 2 directions. In this it's a very straightforward thing. என்ன தெரியுமா? We have both the forces along this line only. The vertical line direction தானா, both the forces are in the same line. அப்ப நம்ம என்ன பண்ணணும்? அந்த direction தான் எடுக்கணும். We'll take that vertical line. இதுல என்ன இருக்கு பாருங்க, tension is upwards and weight is downwards. Total force 0. அப்படி சொன்னா what it means? And the upward force at a value should be equal to downward force தானா. அப்போ தான total force will be 0. Downward force என்னது? Weight which is equal to 80 newtons. புரியுதா? So what they're asking? They're asking the tension force in the rope. Okay. So tension force in the rope எவ்வளவு? It is going to be coming as what? 80 newtons. Okay va? So it's straightforward question. So என்ன பண்ணிருக்கோம் நம்ம? We have just drawn the block or a free body diagram draw பண்ணிருக்கோம். அதுக்கப்புறம் we have just done that balancing of forces. Okay, once you go to next problem you will be able to understand எப்படி அந்த கொஞ்சம் complications வரலாம்னு சொல்லிட்டு. Okay, so this is the approach. அடுத்த question பாருங்க, a block of mass 4 kg is kept on a horizontal table at rest. என்னது பாருங்க, there is a horizontal table எடுத்துக்கோங்க. அதுக்கு மேல we are keeping a block of mass what? 4 kg block. Okay வா? This is at rest. What is the normal reaction acting on the block? இதுல என்ன find out பண்ணணும்? We should find the normal reaction oda value. We should find the normal reaction acting on the block. And the block மேல what is the normal reaction? இதுலயும் அப்படிதான். We have to take the small g oda value என்ன? 10 meter per second square. Okay வா? இங்க பாருங்க. So we will draw the free body diagram for the block. Any object will have its own weight which is vertically downwards. Okay va? So then what is the mass of the block? 4 kg, right? So 4 into acceleration due to gravity equal to 10. So 40 newtons. Okay va? What is this? 40 newtons. அதுக்கப்புறம் வேற என்ன இருக்கும்? Look at this. There is a contact between that the 4 kg block and the surface below. And the ரெண்டுத்துக்கு நடுவுல there is a contact. இதுதான் contact surface. So contact surface பத்தி நமக்கு என்ன தெரியும்? Whenever there is a contact between the two surfaces, there will be two types of forces. One another friction, which will be along that contact plane. But we are going to discuss about it later. So friction, when you want to discuss about the friction, they should give us already. What they should give us? They should give us something called as coefficient of friction and solidity. They should give us some information. Okay. Then what it means? They are asking us to assume that the surfaces are smooth. The friction but additional information kudukalana, what you have to assume? You have to assume that the surfaces are what? Smooth. Okay va? So for the friction பத்தி நம்ம கவலை இல்ல. We are just now going to focus only on what? Normal reaction தான பாருங்க. There will be a normal reaction acting on that block. எப்படி? அந்த contact surfaceல இருந்து perpendicular இருக்கும். It will be going into the block. இங்க பாருங்க. இப்படி வரும். So this is the normal reaction. அவ்வளவுதானா? அதுக்கப்புறம் there will be no more forces. So on that block of mass 4 kg only two forces are there. என்னன்னா, one is the weight of that block, அதுக்கப்புறம் normal reaction. இங்க பாருங்க, both of them here are acting along the same line. ஒரே லைன்ல தான் இருக்கா? One is vertically upwards, ரெண்டாவது vertically downwards. இப்போ நம்ம என்ன பண்ண போறோம்? We have to apply that equilibrium condition because they are saying the block is at rest. Rest and சொன்னது the balancing of force is happening. So இப்போ நம்ம பார்க்க போற எல்லா எக்ஸாம்பிள்ஸ் என்ன தெரியுமா? Balancing of forces. அதுக்கப்புறம் we look at the unbalanced forces. ஓகேவா? Unbalanced force என்ன தெரியுமா? We are going to get the object having acceleration. இப்போ அந்த net force acting on the body is having some value. அப்படி இருந்தா then what is going to be the outcome? The body is going to get some acceleration. Because of that net force, it is going to get some acceleration. Okay, அது நம்ம when we go to that unbalanced force problems, we will look at it. But இப்போதைக்கு என்ன, this is the balanced forces. So இங்க பாருங்க, we will look at this vertical line. So we look at the vertical line. On the vertical direction la we will apply that balancing of forces. Actually இருக்கிறது எத்தனை forces? ரெண்டு force தானா? One is up, ரெண்டாவது down. When you say the total force should be 0, means what? That upward force, another normal reaction, the upward force at a value, right, should be equal to downward force dana, which is what? The weight, that is 40 newtons. So that is the equation we are going to get. Okay va? So these equations, what do we call them as? We will call them as what? The equations for the balanced forces. இதுக்கான சிம்பிளா நீங்க ஞாபகம் வச்சுக்கோங்க. What you are going to do? You have to take a direction. Maximum you can take how many directions? Redirection எடுக்கலாம். Why? Because we assume that the forces are in a plane. அப்படி இருந்தா then we have to choose two mutually perpendicular directions. Like இதுக்கு முன்னாடி நம்ம என்ன பார்த்திருக்கோம்? Horizontal ஒன்னு எடுத்தா then you have to take the other is what? Vertical. Maximum you can take two mutually perpendicular. It's not like you have to always choose horizontal and vertical, but you should choose what? Two perpendicular directions. Okay va? Then you have to apply that balancing of forces condition. Pakala, we'll look at some more examples. Paranga, a block of mass 4 kg is attached with two strings as shown in equilibrium. Equilibrium and sonanadi, the net force acting on that on the block மேல இருக்கிற net force will be what? 0. Okay va? Find the tension in the strings. அந்த strings குள்ள இருக்கிற tension நம்ம find out பண்ணணும். Remember, இந்த மாதிரி ஒரு எக்ஸாம்பிள் ஆல்ரெடி நம்ம பார்த்திருக்கோம். எங்க? While drawing the free body diagram. ஞாபகம் இருக்கா? We have drawn the free body diagram for this particular block. So if you remember that correctly, என்னது? There will be a tension force acting on the block. இந்த பக்கம் ஒரு tension force. அதுக்கு என்ன சொல்லலாம்? T1. ஓகேவா? அந்த மாதிரி இந்த பக்கம் ஒரு tension force இருக்கும். அதுக்கான T2. There will be tension force that side into the இதுக்கான rope 1 அப்படி வெச்சுக்கலாம். இது என்னது? rope 2. There will be a tension force acting into rope 1. அந்த மாதிரி there will be tension force acting into rope 2. ஓகேவா? அதுக்கு அப்புறம் this object is also going to have its own weight. Weight என்னது? Mass of the object times acceleration due to gravity தானா? Acceleration due to gravity எவ்வளவு? 10. Mass எவ்வளவு? 4. So 4 into 10 என்ன? 40. So அந்த object ஓட weight எவ்வளவு? 40. So weight will be vertically downwards. அதுக்கு அப்புறம் அந்த horizontal lineல T1 இருக்கா? ஒரு inclined directionல there is a T2. இப்போ பாருங்க, we have to apply the balancing condition, right? இதுல என்ன தெரியுமா? We will choose horizontal and vertical directions. எந்தெந்த டைரக்ஷன்ல நம்ம இந்த பேலன்ஸ்ட் ஈக்குவேஷன் அப்ளை பண்ண போறோம்? ஒன்னு ஹாரிசான்டல், ரெண்டாவது வெர்டிகல். இங்க பாருங்க, this tension T2 is inclined with how much angle with the horizontal? theta. Already theta கொடுத்திருக்காங்க. What is theta value? Pi by 6. Pi by 6 and சொன்னா what is it? 30 தானா? Pi by 6 and சொன்னா what is it? 30 degrees. Okay. So T2 into cos theta. Horizontal component எவ்வளவு வரும்? T2 into cos theta. அந்த மாதிரி நீங்க பாருங்க, vertical component எவ்வளவு? T2 into sin theta. புரியுதா? So we are taking the T2 because already in the weight is vertical directionல தான் இருக்கா. T1 horizontal, no problem with both of them. Issue is with what? T2 தானா? T2 is making an angle incline direction இருக்கா அப்ப நம்ம என்ன பண்ணணும் we have to take the components of t2 என்னது the horizontal component value எவ்வளவு t2 cos theta அந்த மாதிரி vertical component எவ்வளவு வருது t2 sin theta theta is what pi by 6 ஓகேவா so இதனது t2 cos theta தானா t2 cos theta னா t2 cos 30 எவ்வளவு √3/2 t2 sin theta sin 30 எவ்வளவு half okay so இப்ப பாருங்க what are the forces in the horizontal direction தனித்தனியா நம்ம பார்க்கலாம் so we'll just look at the equation that will come in the horizontal direction first நம்ம the horizontal direction பார்க்கலாம் okay horizontal direction நீங்க சொல்லுங்க what will be the forces that are there என்ன இருக்கா there is a t1 in the left side ல அந்த மாதிரி t2 cos theta is towards the right side அவ்வளவுதான் வெறும் two forces தான் ஒன்னு t1 totally is towards the left side அதுக்கு அப்புறம் t2 ஓட component what is the component of t2 here t2 cos theta அது எந்த பக்கம் இருக்கா t2 cos theta is towards the right side அவ்வளவுதான் so horizontal balanced condition சொன்னனே the left side இருக்கிற component value what is it t1 should be equal to the right side what is the right side t2 into √3/2 அவ்வளவுதான் so நம்ம equation 1 வெச்சுக்கலாம் what is it equation 1 ஓகேவா அதுக்கு அப்புறம் vertical directionல பாருங்க vertical direction என்ன இருக்கா there is a weight எவ்வளவு 40 newtons downwards அதுக்கு அப்புறம் t2 ஓட இன்னொரு component ஏன்னா t2 நம்ம ரெண்டு காம்போனன்ட்டா பிரிச்சிருக்கோம் what is it t2 cos theta is towards the horizontal directionல அந்த மாதிரி t2 sin theta is the vertical பாருங்க t2 sin theta sin theta ன்னு சொன்னனது half so அந்த t2 into half which is t2/2 அதே எப்படி இருக்கா vertically upwards weight vertically downwards balanced condition ன்னு சொன்னனது the vertically upwards t2/2 should be equal to downwards ல என்ன இருக்கா weight தானா 40 newtons so இதுல இருந்து நமக்கு என்ன வரும் ஸ்ட்ரைட்டா t2 ஓட வேல்யூ வரும் t2 is what 2 அந்த பக்கம் எடுத்துட்டு போனா it will be what 2 நியூமரேட்டர்ல போய்டும் so 2 into 40 எவ்வளவு 80 so நமக்கு t2 வேல்யூ வந்தது what is t2 value 80 newtons ஓகேவா அப்படியே எடுத்துட்டு put it in the equation 1 so t1 வேல்யூ வரும் t1 is equal to what t2 80 into √3/2 ஓகேவா so 2 ones are 2 40s total energy 40 √3 newtons வேணும்னா you can just simplify that I mean if you want to have the exact value you can put √3 value as what 1.732 எடுத்துட்டு we can just find out இல்லனா we can just leave it like that okay so what is the tension in the left side இருக்கிற rope what is the tension in that t1 தானா what is it 40 √3 newtons அந்த மாதிரி that inclined rope அதுல tension என்ன what is the tension in the inclined rope 80 newtons நீங்க செக் பண்ணி பாருங்க you should also get the same answers you should also be getting the same answers okay va அடுத்த question பாருங்க so all these are different examples all of them are what on that balanced forces conditions okay two blocks are hanging from the ceiling with the help of two ropes as shown hanging on sonna nama enna edukku porom we will take it as what the equilibrium okay find the tension in each rope idhula parunga there is a rope 1 and madri inga irukka rope 2 so let us say the tension in this is t1 idhula na t2 what you have to find we have to find the tension in each rope we have to find the tension in each rope okay va so eppadi find out pandrathu we have to draw the free body diagram for each object first nam enna edukala we will take the free body diagram for the 4 kg block parunga enadhu we are drawing the free body diagram for the 4 kg block 4 kg block adoda weight evladhi 4 into g dana 4 into 10 40 newtons downward direction irukum parunga the 4 kg block is connected to the rope so tension T2 because that is second rope, right? So on 4 kg block மேல எத்தனை force இருக்கா? 2 forces. One force is அந்த block ஓட own weight, அதுக்கப்புறம் tension, அவ்வளவுதானா? There is no other force. பாருங்க, if you are applying that equilibrium condition means what? ஒரே direction இருக்கு இதுல, vertical line. Equilibrium condition சொன்னது total upward force எவ்வளவு? T2. downwardல 40. so the upward force should be equal to downward force தானா? so வந்தது T2 value வந்தது. what is the tension in that second rope? 40 newtons. என்னது? what is the tension in the second rope? 40 newtons. ஓகேவா? அப்புறம் என்ன? we have to find the tension in the first rope also, right? அதுக்கு நம்ம என்ன பண்ண போறோம்? we are going to look at the free body diagram of the 2 kg block. என்ன பண்ண போறோம்? we are going to look at the free body diagram of the 2 kg block. இது அப்படியே இருக்கட்டும். this T2 value let us leave it as it is. so பாருங்க, 2 kg block ஓட free body diagram. so 2 kg block, இதுல என்ன? 2 kg block ஓட weight எவ்வளவு? 2 into g which is 20. அப்புறம் it is connected to a rope. இந்த பக்கம் rope இருக்கா? இது என்னது? first rope, right? we'll call it as what? tension force என்ன? T1. எந்த பக்கம் இருக்கா? it is up. அந்த மாதிரி carefully observe பண்ணுங்க. the 2 kg block is also connected to the rope 2. the 2 kg block is the rope 2 தானா? 2 kg block is also connected to rope 2. so tension because of the rope 2 will be into the rope 2 தானா? means there will be one more downward force, that is T2, because the 2 kg block is also connected to that rope 2, means there will be a tension force acting on the 2 kg block. அது எப்படி இருக்கும் பாருங்க? the tension force acting on the 2 kg block இந்த பக்கம், because of the rope 2 will be down. tension force acting on the 2 kg block because of the rope above is what? Up. tension force acting on the block in the 2 kg block because of the rope below will be down. அப்படிதானா? like it is like what? the rope above is pulling. அந்த மாதிரி இது எப்படி? it will be pulling down. rope above is pulling up. the கீழ இருக்க rope it will be pulling it down. okay, so இப்போ பாருங்க, the line that we take is still vertical line. here also the condition is what? balanced forces. என்னது? balanced force condition தானா? பாருங்க, upwards only one force, என்னது? T1. the total upward force value should be equal to total downward force. downward ரெண்டு force இருக்கா? என்னது? 20 newtons plus T2. already நமக்கு T2 value தெரியும் அந்த equation 1ல இருந்து. what is the T2 value? 40 newtons. okay, so T1 is equal to what? 20 newtons plus 40 newtons. எவ்வளவு? 60 newtons. so T1 எவ்வளவு? 60 newtons. T2 is what? 40 newtons. T1 is 60 newtons. okay, so all these are very standard questions, guys. இதுல என்ன தெரியுமா? even like if you look at past year NEET papers, நீங்க இந்த chapterல பார்த்தா you will see that they would have given questions on these models. இந்த model based பண்ணது like hanging a block from a pull and the ceiling ல இருந்து, or you have like 2 blocks இப்படி ஒரு arrangement கொடுத்துட்டு they will ask what is the tension in the rope 1, what is the tension in the rope 2, அந்த மாதிரி ஒரு problems. okay, so while you practice the past year questions from the chapter, right, if you are not able to get any question or you are getting stuck on you can ask that as a doubt. I will be able to clarify. okay va? so purida, this is what is the balanced forces concept. okay, adukapram we'll go to one more question. this is a very popular one. என்னது? the wedge or inclined plane. என்னது? wedge or inclined plane. இந்த மாதிரி problems பாருங்க, a block of mass 2 kg is held at rest. இது அப்படிதான். when you see the word rest, என்னது? the condition of balanced forces. என்னது? the condition of the balanced forces. a block of mass 2 kg is held at rest on an inclined plane. இதுதான் inclined plane. it is held எங்கது? it is held at rest on the inclined plane. எங்க இருக்கு அந்த block? 2 kg block எங்க இருக்கா? it is on the inclined plane. ஓகேவா? it is held at rest on an inclined plane by applying a force along the plane upwards. எப்படி இங்க பாருங்க, this is the force they are talking about. எது பத்தி they are talking about in this question? They are talking about the force. இப்படி like you are applying a force along the plane upwards. ஓகேவா? அந்த force which தான் you are able to balance that block. அந்த force which தான் you are able to balance that block. Okay, இதுல இன்னொன்னு நீங்க கேர்ஃபுல்லா வெச்சுக்கணும். There is no concept of friction. ஆல்ரெடி நான் சொல்லியிருக்கேன். When we will go to problems in friction, இந்த ரெண்டு contact surface நடுவுல if there is a friction, right, then in those problems where there is a friction, they will be giving us information about something called as coefficient of friction. And the coefficient of friction பத்தி mention பண்ணலன்னா then what is it? We will be like on a highway. So we are having the assumption that these are all what? Smooth surfaces. Friction பத்தி நம்ம we should not even think about the friction. Okay, so பாருங்க, the block of 2 kg is held at rest on an inclined plane. The inclined plane மேல we are holding that block at rest by applying a force along the plane upwards. இப்படி இல்ல என்ன ஆகும்? what happens? நீங்க அப்படியே ஒரு inclined plane மேல ஒரு block வச்சு பாருங்க, what is going to happen? அந்த block அப்படியே கீழே வந்துட்டே இருக்கும். The block will keep coming down. எதுக்கு தெரியுமா? we will know what is the reason why the block keeps coming down. ஒரு inclined plane மேல you just keep an object. It's a very common thing, right? நீங்க அந்த என்னது ஒரு if you go to some theme park or know these water wonderla அந்த மாதிரி இடத்துக்கு நீங்க போனா, that is what is the main concept, right? You have an inclined path. So மேல உட்கார்ந்தனா you will keep coming down, right? That's a very popular activity for the children. So why you keep coming down? For surface smoother irundha vechukonga, then the block agatum, or if you are sitting at the top of the plane, you will keep coming down. Why? We will be able to know the answer in some time. Okay va? But and the block appadi varakudadanu solittu you are applying a force along the plane upwards. Ipdi the question is, what is the value of this force? So how much force you should apply along the plane upwards so that you are able to hold this on the 2 kg block? We should hold this at rest. Okay va? So this is an interesting question. And this is a question what we call as a block on the inclined plane. So it's a very popular one. Another block on the inclined plane. Okay, so before in the question number solve பண்றதுக்கு முன்னாடி I will show you, forget about this in the force பத்தி let us just forget about for some time. Let us look at what is the இதுக்கு முன்னாடி before you apply this force, what are the forces already existing on the block? And the 2 kg block மேல what are the forces existing? நீங்க பாருங்க, இதனது this is the contact surface. In the particular situation la contact surface is what? Inclined plane தானா? Contact surface is the inclined plane. So normal reaction எப்படி இருக்கும்? On the inclined plane perpendicular வரும். So the normal reaction will be what? Perpendicular to the inclined plane. So we are looking at the normal reaction acting on the 2 kg block. Appa enadhi? The normal reaction will be going into the 2 kg block dana. That is how normal reaction is going to be. In the particular inclined plane case la enna varum? Normal reaction will not be vertical. Normal reaction will be what? Perpendicular. Inga parunga, normal reaction is what? Perpendicular to the inclined plane. Another normal reaction is what? Perpendicular to the inclined plane. Idhula enna theriyuma? I want you to just recall. Already I'm on the, when you talk about the directions of balancing of forces, we can take maximum 2 directions which are perpendicular to each other. Usually we will take horizontal, vertical, but in the particular case la mattum, in which case? The inclined plane case. So what is it? In case of the inclined plane, and the inclined plane problems irukku theriyuma, on the particular case la we will look at the 2 directions as one direction will be along the plane, rendavathu perpendicular to the plane, because we can take 2 perpendicular directions, right? One enadhi along the plane. Paranga, along the plane is one direction where we will apply the balancing of the forces. Adukaprom perpendicular to the plane andha madri we will choose along the plane. Paranga, both will be perpendicular to each other. Normally நம்ம அந்த balancing condition use பண்ணும்போது we will choose two directions, right? Normally what do we choose in all the previous problems? We are choosing what? We are choosing horizontal vertical dana, but in this particular case of inclined plane, another in this particular case of the inclined plane, okay va? Idhula nam enna edukka porom? We are going to choose the directions as what? Along the plane and perpendicular to the plane, okay va? We will choose the directions as what? Along the plane and perpendicular plane, okay? So normal reaction முடிஞ்சது. அதுக்கப்புறம் there will be no friction force. Why? Because we are assuming smooth. இங்க பாருங்க, there will be one more force which is the weight of that block. என்னது? There will be weight of that block. Weight will be always what? பாருங்க, it will be always what? Vertical. Weight will be always what? Vertical. Okay. So this is a very important thing. It's like a standard result. இது நம்ம அப்படியே ஞாபகம் வச்சுக்கலாம். Because we'll keep using this in lot of problems. Let's say in the block, this is the block. Angle of the inclined plane theta. What is the angle of the inclined plane? Theta. How the weight will be acting? Vertically downwards dana. Weight vertically downwards. If you complete this triangle, the triangle complete panna vechkonga, it will be a right angle triangle. So this is theta, means in a right angle triangle, ஒரு angle theta னா இன்னொரு angle என்ன வரும்? 90 minus theta தானா? பாருங்க, we have to take the component of the weight. Weight எப்படி இருக்கா? Vertically downwards. We have to take the components of the weight along the plane. இங்க பாருங்க, weight எப்படி இருக்கா? Weight is vertically down. இந்த component எடுத்தா என்ன வரும்? You will get a component along the plane downwards. ஒரு component எப்படி வரும்? Along the plane downwards. ரெண்டாவது perpendicular to the plane, that is also perpendicular to the plane downwards. Okay va? So if you resolve the weight நம்ம resolve பண்ணா, you will get two components. One component is what? Along the plane downwards. One component is what? Along the plane downwards. ரெண்டாவது perpendicular to the plane, அதையும் downwards தான். Now I'll tell you the reason why. நீங்க அந்த inclined plane மேல அப்படியே உட்கார்ந்து வெச்சுக்கோங்க. Then what happens? I said you will be coming down. எதனால தெரியுமா? பாருங்க, the component of the weight ஓட ஒரு component எப்படி இருக்கா? It is along the plane downwards இப்படி. So this component of weight along the plane, this component of weight along the plane is the reason why we will keep coming down the plane. புரியுதா? So there is a component of the weight along the plane. அதனால தான் we'll keep coming down. We'll keep coming down the plane. Why? Because there is a component of the weight which is along the plane downwards. Okay. So இப்போ நம்ம என்ன பண்ண போறோம் தெரியுமா? We are going to look at what are these components of the weight values. What are these component of the weight values? This is a very standard result. So once we do it right, நீங்க அப்படியே ஞாபகம் வச்சுக்கலாம். Because you know we'll be able to use it in every problem. So இங்க பாருங்க, this is weight which is vertically downwards. Already நான் மார்க் பண்ணிருக்கேன். இது என்ன 90 minus theta means இந்த பக்கம் இருக்கிற angle என்ன தெரியுமா? theta வரும். யோசிச்சு பாருங்க. So this is what? இது என்னது? 90 minus theta தானா? This is normal to the plane. So 90. இந்த பக்கம் 90. இதனை 90 minus theta சொன்னா this will be what? Theta. Okay va? So the mg weight is making an angle theta with the normal to plane. அப்போ normal to plane component எவ்வளவு வரும்? mg cos theta வரும். So weight is making an angle theta with the normal to plane. அப்போ normal to plane component எவ்வளவு வரும்? It will be what? mg cos theta. அந்த மாதிரி இன்னொரு component என்ன? The component which is parallel to the plane. பாருங்க, the component which is parallel to the plane, அது என்ன வரும்? What will be the component? So this is mg cos theta சொன்னா, what will be the other component? mg sin theta தானா? What will be the other component? mg sin theta. This is what I was saying as a standard result. ஒரு inclined plane மேல you are keeping a block ஆகட்டும் or any object வெச்சுக்கோங்க. Then when you resolve ன்னு சொன்னா என்னது? A vector can be taken into the components. அதுக்கு தான் நம்ம resolve ன்னு சொல்லுவோம். Okay. So if you take the vector into the components, the component along the plane oda value anadi mg sin theta. Okay va? What is the component of the weight along the plane? Mg sin theta. And the madri, what is the component of the plane? Component of the weight perpendicular to the plane, adanadi mg cos theta. Okay, so idu rendu nama appadiye gnapagam vechukonum. So now I will come to the final step. So these are the results we need to have. These are the results that we will have, so that we will be able to easily solve problems. Idukaprom, if there is any question on the inclined plane, right, we will be able to easily tell what are the components of the weight. On the inclined plane mele, let's say there is an object, and the object of the weight we can take components. Ipo parunga, in this question only, right, weight evalade, what is the weight? Object mass 2 kg, g 10. Appo weight evalu varum? 20 newtons dana. Weight evalu varum? 20 newtons. Inga parunga, I want to take the components. I want to take the components of the weight. Component of the weight normal to the plane. Adanadi mg cos theta dana. Component of theta evala? Theta is what? 60 inga. What is the angle of the inclined plane? 60. Okay. So mg cos theta adanadi mg 20 newtons into cos 60 evala? Half. So total anadi 10 newtons. Adha the component of the weight perpendicular to the inclined plane. Adukaprom we have a component of that weight which is along the plane downwards. Component of the weight along the plane downwards. Adanna mg sin theta dana. Mg sin theta anna, what is it? Mg 20 sin 60. Sin 60 evala? 10 root 3 newtons. Okay va? So ipo parunga, we have normal reaction already in the direction irukka. It is normal to the contact plane. The applied force is along the plane. Applied force nama or force apply pannirukku theriyuma? Adu eppadi irukka? Along the plane. Weight mattum is vertically downwards. Adu nama resolve pannirukom. So we have taken the components of the weight. One component is along the plane, rendavathu perpendicular to the plane. So now what we will do is, we will look at the equations. Idhula nam enna pannom? We have to look at the balancing of forces. Now we have to look at the balancing of forces. First enna theriyuma? We will look at perpendicular to the plane. Parunga, perpendicular to the plane, ethana force irukka? There is a normal reaction which is perpendicular to the plane up. Adukaprom there is a component of the weight which is perpendicular to the plane down. Avladha. Adukaprom there are no perpendicular to the plane forces. We are looking at the balanced. They are saying Bach is at rest. Rest and the balancing of the forces dana, which means on the force which is perpendicular to the plane upwards, other the value should be balanced by what? The component of the weight which is perpendicular to the plane downwards. So idhilendhu namakku enna varudhu? Normal reaction oda value varudhu. What is the normal reaction? 10 newtons. Evaladhi? What is the normal reaction value? 10 newtons. Okay, but in the problem namakku indha value thevilla. Why? Because they are not asking us normal reactions. Parunga, they are asking us what is the value of this force? And the force that is applied along the plane upwards to keep the block at rest. Inga parunga, along the plane, in the perpendicular to the plane, and the case mudinjadu. Now we are looking at what? Along the plane, in the direction along the plane. So along the plane parunga, enna irukka? There is the applied force which is along the plane upwards, and there is a component of the weight another mg sin theta which is along the plane downwards. Restance on another balancing condition dana, which means the force along the plane upwards, adu f ani vechukonga. Adha nama find out pannom. The force along the plane upwards should be equal to what? The force along the plane downwards. Adanadi the component of the weight along the plane. What is it? mg sin theta. Adoda value enna in the particular case la 10 root 3 newtons. Avladha. That is what we are looking for. What is the answer for this? 10 root 3 newtons. That is the force that is applied along the plane upwards, so that the 2 kg block on that on the particular inclined plane மேல இருக்கிற 2 kg block will be at rest. Okay வா? So இதுல என்ன தெரியுமா, we have covered one important result. என்னது? when we are looking at the balancing of forces for an object on the inclined plane, on the inclined plane மேல இருக்கிற object, if you want to do the balancing of forces, right, அது நம்ம எப்படி பண்றது? we will look at the two directions. என்ன? the parallel to the plane, அது ஒண்ணு, ரெண்டாவது perpendicular to plane. இப்படி ஒரு situation என்ன தெரியுமா, we will have to take components of the weight, and the object or block or weight components நம்ம எடுக்கணும். so components என்ன வரும்? the component of the weight which is perpendicular to the plane, அது என்னது? always it will be mg cos theta. theta என்னது? theta is the inclined plane angle. okay வா? அந்த மாதிரி the other component of the weight will be mg sin theta, which is going to be down that inclined plane. அதனால தான் when you keep an object or something, or even you go and sit and the inclined plane top ல உட்கார்ந்து வெச்சுக்கோங்க, then what is going to happen? You will keep coming down. Why? Because the component of the weight is acting down the plane. அதனால you will keep coming down. okay வா? so this is what is that resolving or taking components of weight in the case of a block on the inclined plane. so block on the inclined plane, right, this is a very standard model of question. Another block on the inclined plane. திருப்பி நம்ம இந்த same block on the inclined plane concept, right, திருப்பி நம்ம friction case ல பார்க்க போறோம். when we talk about the friction, right, we'll again discuss about it. okay வா? so this is about the idea of the balancing of the forces. next, already நம்ம ஒரு சில common types of force பத்தி பார்த்திருக்கோம். but I said when we go to specific examples, we'll also see some new types of forces. அதுல first new type of force என்னது? buoyancy. we are going to look at this force again in இதுல properties of fluids. எதுல வரும்? properties of fluid chapterல வரும் திருப்பி. okay, buoyancy or upward thrust என்ன தெரியுமா? this is the force exerted on a body which is immersed, either partially immersed ஆகட்டும். இங்க பாருங்க, this is what, இது என்னது? partially immersed or fully immersed. இது என்னது? this is what, இங்க பாருங்க, the object is fully immersed. okay வா? so what is buoyancy? any object, if you partially keep this in liquid, இல்லைன்னா you fully keep this in liquid, then that object will experience upward thrust. எந்த direction இருக்கும்? it will be what? upwards. that object which is partially immersed into that liquid or fully immersed, it will experience an upward thrust due to that liquid. the force is because of what? because of the liquid. the object will experience an upward thrust because of the liquid. அதுக்கு என்ன பேரு? what is the name that we giving for it? buoyancy force ன்னு சொல்லுவோம். buoyancy இல்லனா upward thrust. what is the force called as buoyancy or upward thrust? okay வா? so here I'll tell you what is the value of this buoyancy force. பாருங்க, the buoyancy force will be equal to the weight of liquid displaced because of the immersion. and carefully படிச்சு பாருங்க, what is it? and the immersion நடக்குது, the object is either and partially immersed or fully immersed, right? because of immersion, what is happening? so இதுல பாருங்க, let's say this, நான் ரெட்டா மார்க் பண்ண வால்யூம் பாருங்க, this is what VD ன்னு வெச்சுக்கோங்க. அதனே தெரியுமா, that much amount of the solid is going into liquid means அந்த வால்யூம்ல இருக்கிற, இதுக்கு முன்னாடி என்ன இருக்கும்? அதுல there will be liquid, right? that much amount of the liquid is displaced. so whatever the immersion volume, இங்க பாருங்க, this is the immersion volume. இதுல என்ன வரும்? full case means, fully immersion means what? the object is fully immersed means what is the volume of the liquid displaced? என்னது? the volume of the liquid displaced is what? the full volume of the body. volume of the liquid displaced is what? the full volume of the body. okay va? So the buoyancy force will be equal to what? It will be equal to weight of the liquid displaced because of the immersion. Let us say Vd is the volume of the liquid displaced. Vd enna theriyuma? Vd is nothing but the volume of liquid displaced, which will be equal to the volume of object immersed. Adana volume of the liquid displaced and sonna, what is it? The volume of the object that is immersed. Ipo parunga, in the particular case la let us say the total object oda volume 4 centimeter cube vechukonga. Konjam it's just partially immersed ana. Let's say ஒரு 1 centimeter cube volume is immersed. அப்போ வீடியோட வேல்யூ என்ன வரும்? 1 centimeter cube. ஏன்னா இந்த ஆப்ஜெக்ட் 1 centimeter cube உள்ள போனா that 1 centimeter cube of volume of the liquid is coming out, displaced. But in the second case paranga, fully immersed, and the total object fully immersed means what? How much is the volume of the liquid displaced in the particular case? It will be what? Total 4 centimeter cube. Okay va? So if Vd is the volume of the liquid displaced, it is nothing but the volume of the object that is getting into the liquid. Avladha, simple. The volume of the object that is getting into the liquid. Okay. If a buoyancy oda formula enna? What is the formula for the buoyancy? Weight of the liquid displaced because of the immersion. Weight and sonna enadhi? Ipo and the liquid volume எவ்வளோ டிஸ்பிளேஸ் ஆயிடுச்சுன்னு சொல்லிட்டு நமக்கு தெரியும். Vd say rho density of liquid. Generally நம்ம density எப்படி தெரியுமா? We will use the symbol rho இல்லனா d, but we will try to avoid d. Why? Because d is also used for distance. அதனால we will use the symbol rho. Okay, so rho is what? இப்படி like you will write it like a curved p madri. That is what we call as what? How do you spell it? As rho. So rho is what? Density of the liquid. Okay, so inga parunga, density of the liquid into the volume of the liquid displaced. Ninga density into volume panna enna varum? Mass of the liquid displaced dana. Another density into volume panna enna varum? Mass of the liquid displaced. But நமக்கு என்ன வேணும்? Weight of the liquid displaced வேணும். Weight என்ன? Mass of any object. Weight will be equal to what? Mass of the object times acceleration due to gravity தானா? So பாருங்க, finally நமக்கு buoyancy ஓட value வந்தது. What is it? The buoyancy force is equal to what? Rho into Vd into G. அவ்வளவுதான். இதுல rho என்னது? The density of the liquid. Vd is what? The volume of the liquid displaced. Vd is what? The volume of the liquid displaced. Okay va? It is also nothing but the volume of the object immersed. அப்படி நம்ம சொல்லலாம். So rho into Vd into G இதுதான் buoyancy ஓட value. Okay va? So we will stop it here for today. நீங்க ஒன்னு பண்ணலாம். You can try and tell me before you meet in the next session. I have straight away told you what is the buoyancy value. I said buoyancy force is equal to what? Weight of the liquid displaced. அப்படியே ஒரு ஸ்டேட்மென்ட் மாதிரி நான் கொடுத்திருக்கேன். I said, what is it? The buoyancy is weight of the liquid displaced. But why the buoyancy is equal to weight of the liquid displaced? Why the buoyancy is equal to weight of the liquid displaced? You try to tell me the answer for this before we meet in the next session. Okay va? So adukkum we can do one small derivation. Okay, we will do in the next session. If you are not able to get the answer, we can derive it and show how the buoyancy force will be equal to the weight of the liquid displaced. So what is the buoyancy force? We are saying buoyancy is equal to weight of the liquid displaced, right? அது எப்படி வருதுன்னு சொல்லிட்டு we can also do a derivation for that. Okay va? So இப்போதைக்கு என்ன? We'll just look at this formula for the buoyancy force. What is it? Rho into Vd into G. இதுல rho என்னது? Density of the liquid. அதுக்கப்புறம் Vd is what? the volume of the liquid displaced. And the madri G is what? Acceleration due to gravity. Okay, va? So this is what is the concept of buoyancy or the upward thrust. Okay, we'll see in the next session.